welcome back guys. Welcome back once again. So we have started a new chapter, that is mechanical properties of solid, and we have studied so far what do you mean by stress, what do you mean by strain, what do you mean by solid, and what are the kind of stress, what are the kinds of stress, and everything we have studied up to this. Like stress is we have also studied, first let us make sure that we have studied deformation force, and with respect to that deformation force, some internal forces are developed in the body. If you apply new deformation force hakidre body mega, internal restoring forces develop aagtavu. Hauda, our restoring forces sir. If I calculate the cross section area divided by restoring force, or you can say force divided by area, force restoring force divided by area ಮಾಡಿದಪ್ಪ ಅಂತಂದ್ರೆ ಒಂದು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಬರ್ತೈತಿ, ಅದಕ್ಕೆ ನಾವು ಏನಂತೀವಿ ಸ್ಟ್ರೆಸ್ ಅಂತೀವಿ, ರೈಟ್? ಸೊ ಸ್ಟ್ರೆಸ್ ಯೂನಿಟ್ ಏನು, ನ್ಯೂಟನ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಅಥವಾ ಪಾಸ್ಕಲ್ಸ್ ಅಂತೀವಿ ಅದಕ್ಕೆ. Then we also calculated or also found the dimension of the stress, and with related to stress there are three kinds of stress mainly we have divided. One is the tensile stress, if the force acting on the body is along the axis the path marada tensile ಅಂತೀವಿ. ಟೆನ್ಸೈಲ್ ಒಳಗೆ ಮತ್ತು ಲಾಂಜಿಟ್ಯೂಡ್ ಅಂತೀವಿ. ಲಾಂಜಿಟ್ಯೂಡ್ ಮತ್ತು ಯಾರು ಬರ್ತಾವೆ, ಒಂದು ಟೆನ್ಸೈಲ್ ಒಂದು ಕಾಂಪ್ರೆಸಿವ್. ಹಿಂಗೆ ಫೋರ್ಸ್ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಟೆನ್ಸೈಲ್ ಅಂತೀವಿ, ಹಿಂಗೆ ಫೋರ್ಸ್ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಕಾಂಪ್ರೆಸಿವ್ ಅಂತೀವಿ. Then we also stated that there is another kind of stress, that is a tangential stress. It is also called as the shear stress. Hang force acting to the three along the free surface of the body act ಆಗ್ತಿರುತ್ತೆ. ಅಂತ ಫೋರ್ಸ್ ನಾವು ಏನಂತೀವಿ, ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್ ಫೋರ್ಸ್ ಅಂತೀವಿ. ಮತ್ತು ಸ್ಟ್ರೆಸ್ ಡೆವಲಪ್ ಏನಂತೀವಿ, tangential stress. And also studied that there is another kind of force, or you can say stress, if the force is acting along in all the direction on the body, on the surface of the body. ಎಲ್ಲ ಕಡೆಯಿಂದ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗಲಾಕತ್ತೈತಿ ಬಾಡಿ ಮ್ಯಾಗಪ್ಪ ಅಂತಂದ್ರೆ ಅಂತ ಫೋರ್ಸ್ ನಾವು ಏನಂತೀವಿ, ಹೈಡ್ರಾಲಿಕ್ ಫೋರ್ಸ್ ಅಂತೀವಿ. and stress developed is called as hydraulic stress. And with respect to these things, with respect to the thing force acting and deformation, all those things, there are three kinds of stress, strain. ಒಂದು longitudinal strain, ಇನ್ನೊಂದು ಹೈಡ್ರಾಲಿಕ್ ಸ್ಟ್ರೈನ್, ಇನ್ನೊಂದು ಶಿಯರ್ ಸ್ಟ್ರೈನ್. ಅದನ್ನೆಲ್ಲ ಕಲ್ತೀವಿ, ಏನೇನದ ಅಂತ ನೋಡಿವಿ. ಈಗ ಭಾಷಣ ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ, ತಿಳ್ಕೊಂಡು ಡೆಫಿನೇಷನ್ ಬರ್ಕೊಳ್ಳಿ ಅಂತ. ಎಕ್ಸಾಂಪಲ್ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ಲೆಟ್ ಅಸ್ ಹ್ಯಾವ್ ಅಂಡ್ ಬಾಡಿ, ಒಂದು ಬಾಡಿ ತಗೊಳ್ಳೋದು, ರೈಟ್? ಐ ಹ್ಯಾವ್ ಟೇಕನ್ ಒನ್ ರಾಡ್ and I have applied force on it. Let us apply force on it, right? ಇದನ್ನ ಡಯಾಗ್ರಾಮ್ ಹಾಕಿ ನೋಡ್ರಿ. If I take in body, same example, a rod which is fixed at one end, ಅದನ್ನ one end fix ಮಾಡೋಣ, ಇನ್ನೊಂದು ಎಂಡಿಗೆ ಟೆನ್ಸೈಲ್ ಫೋರ್ಸ್ ಹಾಕೋಣ. ಹೌದಾ? ಟೆನ್ಸೈಲ್ longitudinal force, ಟೆನ್ಸೈಲ್ ಫೋರ್ಸ್ ಹಾಕೋಣ, ರೈಟ್? Now if I apply the force, ಇದನ್ನ ಹಿಡಿದು ಜಗ್ಗ ಹಾಕ್ತೀನಪ್ಪ ನಾ ಅಂತಂದ್ರೆ ಏನಾಗ್ತದ್ರಿ, ಬಾಡಿ elongation ಆಗ್ತದೆ. ಹೌದಾ? Length of the body goes on increasing, right? So length of the body goes on increasing. So initially ಎಷ್ಟಾಗ್ತೈತಿ, ನಿಮಗೆ ಒಂದು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ಕೋತಿರಪ್ಪ ಅಂದ್ರೆ length of the body goes on increasing, right? Length of the body goes on increasing means as I am increasing the force, now force ಹೆಂಗೆ ಹೆಚ್ಚು ಮಾಡಲಾಗ್ತಿಲ್ಲ ಹಂಗ ಸ್ಟ್ರೆಸ್ ಏನಾಗ್ತದೆ, ಹೆಚ್ಚಾಗ್ತದೆ ಕಡಿಮೆ ಆಗ್ತದೆ. Stress is, if I write the formula for stress is equals to force divided by area. ಹೌದಿಲ್ಲ? ನಾವು ಬಾಡಿ ಚೇಂಜ್ ಮಾಡಲಾಗಿವಿ, ಬಾಡಿ ಅದ ಐತ್ರಿ, ಬಾಡಿ is not going to change. I am only changing the applied force, or I can say that I am only increasing the applied force. If I increase applied force means obviously stress is also increasing, being this constant. ಇದು ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತದೆ, ಹೌದಾ? Now I can say that if the force is increased, if I apply more and more force, certainly stepwise now force ಹೆಚ್ಚು ಮಾಡ್ಬೋದು ಹೋದಪ್ಪ ಅಂದ್ರೆ ಸ್ಟ್ರೆಸ್ increase ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಹೌದೋ ಇಲ್ಲೋ? ಹೌದು, ಎಕ್ಸಾಕ್ಟ್ಲಿ, ಬಿಕಾಸ್ for this reason, right? Next, I found that if the force go on increasing means stress is also go on increasing. What about the change in length? If I apply suddenly first 10 Newton of force, right? Elongation may be this much, right? If I increase to 20 Newton force, then elongation may be this much. ತಿಳಿಲಾಗ್ತದೆ, ಮೊದಲು elongation ಇಷ್ಟು, ಆಮೇಲೆ elongation ಎಷ್ಟಾಯ್ತು, ಇಷ್ಟಾಯ್ತು, right? Now suppose I apply 30 Newton of force. What will happen? Elongation becomes much more. what I want to tell is, as the force increasing, what about the strain? Strain and another. What is the formula for strain? Strain is equals to change in length divided by original length. I am taking length because it is a tensile, right? It is a longitude. So change in length divided by original length. Now, if I increase the force, common sense is telling that if I increase the force, change in length also increases. Change in length if the change in length is increasing, means strain is also increasing. Means whenever I increase the force stepwise, then I can say that strain is also increasing, isn't it? Strain is also. Now consider this. Suppose the force is 10 Newton initially. Force is 10 Newton initially. For this, stress increases and also strain increases. Right? Both increasing. Then I apply 20 Newton. Stress increases, strain also increases. Then I apply 30 Newton. Then stress, strain both are increasing. Right? Getting my point? But this happens up to a particular fixed point, up to a particular fixed force. Right? Up to particular fixed force. That fixed force or that fixed point is nothing but the elastic limit. Right? So this process, what I want to tell here is, as the stress increasing, strain is also increasing. Can I say like this? Stress and strain are directly proportional to each other. If the stress is increasing, simultaneously strain also increases. ಹೌದಾ? ಸ್ಟ್ರೆಸ್ ಹೆಂಗೆ ಹೆಚ್ಚಾಕೋತ ಹೋಗ್ತದೆ ಹಂಗೆ ಸ್ಟ್ರೇನ್ ಹೆಚ್ಚಾಕೋತ ಹೊಂಟೈತಿ. ಎರಡು ಈಕ್ವಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಈಚ್ ಅದಾವ ಅಂತ ಹೇಳ್ಬೋದು, ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಅಂತ ಹೇಳ್ಬೋದು. ಎಲ್ಲಿ ಮಟ್ಟ ಪ್ರಪೋರ್ಷನಲ್ ಇರ್ತಾವ್ರಿ? ಅಪ್ ಟು ದ ಇಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್. ಇಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ 40 ನ್ಯೂಟನ್ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಇದ್ರ ಇಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಎಷ್ಟೈತಿ? ಗಿವನ್ ಬಾಡಿ 40 ನ್ಯೂಟನ್ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. 35ರ ಮಟ್ಟ ಇವನ್ 40 ನ್ಯೂಟನ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರು ಸ್ಟ್ರೆಸ್ ಸ್ಟ್ರೇನ್ ಪ್ರಪೋರ್ಷನಲ್ ಇರ್ತಾವೆ. ಯಾವಾಗ ನೀವು 45 ನ್ಯೂಟನ್ ಅಪ್ಲೈ ಮಾಡ್ತಿಲ್ಲ, these two are not proportional. Stress may be increased. This condition, stress may be increased. But strain start decreasing. ಆಗ್ತೈತಿ. ಯಾರು ನೋಡಿದ್ರು ಇದನ್ನ ಫಸ್ಟ್? ಯಾರು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದ್ರು? The person who. This experiment is performed by first Hooke, and he stated one law that is called as a Hooke's law. It is a very simple. What we have seen now. That is what the law is. Okay? What it says, stress and strain are directly proportional to each other. Right? For a given body, stress and strain are directly proportional to each other under elastic limit. Under certain limit that is called as elastic limit. If this is elastic limit, up to this force, this one is the elastic limit. Up to this force, 40 Newton force, stress and strain are directly proportional to each other. Once the 40 Newton force crosses, means applied force crosses the 40 Newton, then stress and strain are not proportional to each other. Getting my point? So let me write the statement for the Hooke's law. Hooke's law states that for a given body, or you can also say that for a given material, for a given body, stress is directly proportional to strain under, or you can say within elastic limit. Right? So from the statement I can write stress proportional to strain. Right? It is a proportionality symbol. If I want to remove that proportionality symbol, then I should keep one constant ಇಟ್ಟು ನಾನು ಅದು ಪ್ರಪೋರ್ಷನಾಲಿಟಿ ಸೈನ್ ತೆಗಿಬೇಕಾಗ್ತದೆ. So I write stress is equal to E times strain. So what is this E is? So this E is constant that is called as proportionality limit or the elastic limit. Right? So elastic limit E can be defined as stress divided by strain. And its unit is another unit. Can you guess? Stress divided by strain is there. Strain, what is the unit of strain? It is a unitless. Obviously, it is a unitless, isn't it? Then what is the unit of stress? So its unit is Newton per meter square. Right? It is the unit of stress divided by unitless. It is a 1. So unit of the stress is Newton per meter square, and dimension it is kg meter per second square. Kg meter per second square multiplied by meter square. Right? It is nothing but Newton meter square. So here meter raised to -2 and meter raised to +2, it becomes kg m raised to -1 second raised to -2. Then the dimension will be m l raised to -1 t raised to -2, same as that of the stress. Right? So this is regarding the elastic limit and Hooke's law. It is a very important statement, or it is a very important block for your examination. So make perfect of the statement and what is the unit and what is the formula and all those things you have to keep it remember. And elastic limit, as we know, there are three types of stress and 3 types of strain. So depends upon the type of stress and strain, we can classify elastic limit as 3. Right? 3 type elastic limit irtavu. Etra ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರ್ತಾವ್ರಿ ಅವು? ಸ್ಟ್ರೆಸ್ ಮತ್ತು ಸ್ಟ್ರೈನ್ ಮೇಲೆ. 3 ಟೈಪ್ ಸ್ಟ್ರೆಸ್ ಅದಾವ, 3 ಟೈಪ್ ಸ್ಟ್ರೈನ್ ಅದಾವ. ಸೊ ಯಾವ್ಯಾವ ಸ್ಟ್ರೆಸ್ ಗೆ ಯಾವ್ಯಾವ ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಬರ್ತೈತಿ ಅದನ್ನ ಮುಂದೆ ನೋಡೋಣ ಅಂತ. ಅದಕ್ಕಿಂತ ಮೊದಲು ಸ್ಟ್ರೆಸ್ ಸ್ಟ್ರೈನ್ ಡಯಾಗ್ರಾಮ್ ಅಂತ ಬರ್ತೈತಿ, ಅದನ್ನ ಸ್ಟಡಿ ಮಾಡೋಣ. ದಟ್ ಇಸ್ ಆಲ್ಸೋ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಯು ಜಸ್ಟ್ ಟೇಕ್ ಅ ಸ್ಕ್ರೀನ್‌ಶಾಟ್ ಆಫ್ ದಿಸ್ so that we can move further. Okay, so let us move to the next concept, that is stress strain diagram. Here first stress strain diagram andre we will understand what do you mean by stress strain diagram. See, stress strain diagram is a graph obtained by taking stress along the y-axis and strain along the x-axis. So it is nothing but the graph. It is a graph. Hang on to by taking. It is obtained by taking stress along y-axis and strain along x-axis. So I can say that it is the x-axis and it is what? The y-axis. So whatever the curve I am obtained by taking stress along the y-axis and strain along the x-axis, that curve, that diagram is nothing but stress strain diagram. So here I can say that y, it is y term and it is x-axis. Right? So it is what? X-axis. So it is what? The stress strain diagram. If we hang button, say this is a practically obtained graph. If we hang practically obtained graph, hang practical marker again marker. I'll take an example. If a rod is taken, ಒಂದು ರಾಡ್ ತಗೋತಾರೆ, ಅದ್ರ ಮೇಲೆ ಲೋಡ್ ಅಪ್ಲೈ ಮಾಡ್ತಾರೆ. ರೈಟ್? ಸೊ ಫಸ್ಟ್ ತಿಳ್ಕೊತ ನೀವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಕೊತ ಹೋಗ್ತೀನಿ ನೋಡ್ರಿ, ಭಾಳ ಚಂದ ತಿಳ್ಕೊರಿ. ನೀವು ಬರೆಯೋದು ನೀವು ಬರೀತೀರಿ, ನಾನು ಆಮೇಲೆ ಬರೋದು ಮತ್ತೊಮ್ಮೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. ಈಗ ಬರೀ ವರ್ಡಿಂಗ್ಸ್ ಒಳಗೆ ಹೇಳ್ಕೊತ ಹೋಗ್ತೀನಿ, ಈಗ ಕೇಳ್ಕೊತ ಹೋಗ್ರಿ ಏನೇನು ಹೆಂಗೆ ಆಗ್ತೈತೆ ನೋಡು. ಸಿ ವಾಟ್ ವಿ ವಿಲ್ ಡೂ ಇಸ್, ಏನು ಮಾಡೋಣಪ್ಪ ಅಂದ್ರೆ ಒಂದು ರಾಡ್ ತಗೊಂಡು ಅದ್ರ ಮೇಲೆ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡೋಣ. ಇನಿಷಿಯಲಿ ಐ ಆಮ್ ಅಪ್ಲೈಂಗ್ ದ ಫೋರ್ಸ್. See, as I am applying the force, initially when I apply the force, like force is go on increasing 10 Newton, 20 Newton, 30 Newton, 40 Newton. Like this I am going increasing the force or you can say deformation force, and going increasing and increasing and increasing. We know that in the previous concept, we know that as the force is increasing, stress increases, hence the strain. Right? So these two are directly proportional to these two are directly proportional to each other under certain limit. That certain limit is called the elastic limit. So as I am going increasing, so suppose 10 Newton. If I increase the 10 Newton, stress becomes this much. Stress becomes this much, and strain becomes this much. Right? Furthermore, if I go on increasing the stress or force, stress go on increasing. Certainly, the strain is also go on increasing. Stress increase ಆಗಲಿಲ್ಲಪ್ಪ ಅಂದ್ರೆ ನಾವು ಹಿಂಗೆ ಬಳಸ್ಕೊಂಡು ಹೋಗ್ತೀವಿ ಕರ್ವ್ ಮ್ಯಾಗ ಹೋಗ್ತೀವಿ ಹೌದಾ ಅದೇ ಸ್ಟ್ರೇನ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ಬೋದು ಹೋಗ್ತಪ್ಪ ಅಂದ್ರೆ ಹಿಂಗೆ ಹೋಗ್ತೀವಿ ಸೊ ಫ್ರಮ್ 0 or you can say from O to as I am going from right hand side means strain is go on increasing from 0 to upward means stress go on increasing, right? So now what is happening here is as load is increasing deformation force hang ಹೆಚ್ಚಾಗೋದು ಹೋಗ್ತೈತೆ ನೋಡ್ರಿ ಹಂಗ stress and strain ಯಾರು increase ಆಗೋದು ಹೋಗ್ತವೆ so the curve becomes like this, right? Inclined linear curve ಬರುತ್ತೆ up to OA ಮಟ ಏನಾಗ್ತೈತಿ curve linear ಹೋಗ್ತೈತಿ, right? So under this limit, under this OA I can say that stress is directly proportional to strain. ಎಲ್ಲಿ ಮಟ ರೀ O to A ಏನಾಗ್ತದೆ stress is directly proportional to strain. So I can say this point A is proportionality limit, or I can say that it is elastic limit, right? It is what the proportionality limit, right? So the elastic limit is the proportionality limit, right? Thereafter ಏನಾಯ್ತು ಫಸ್ಟ್ ಏನಾಯ್ತು ಹಂಗ ನಾವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ಕೊತ ಹೋದ್ವಿ ಹೆಂಗ್ ಬರೆದ್ರಪ್ಪ ಅಂದ್ರೆ OA ಹೆಂಗ್ ಪಾಯಿಂಟ್ ಬರೆದು OA ಅಂತ ಬರೆಯೋದು ಅಲ್ಲಿ ಜಸ್ಟ್ OA ಅಂತ ಹಾಕೋದು OA. So as the force is increasing, then stress, strain both are increasing up to the point A. So point A is called the proportionality limit. This is one first sentence I think. Next, furthermore, ಎಲ್ಲಿ ಮಟ್ಟ ಆಯ್ತು ಇದು ನಾವು 20 kN ಹಾಕಿದ ಮಟ್ಟ ಆಯ್ತು. So up to this I can say that force is 20 kN. So up to the 20 kN proportionality limit is there. Then furthermore, as I am go on increasing the force, then furthermore if I apply 22 Newton force, as I apply the force, furthermore 22 Newton ಮಾಡಿದ ಪಾತ್ರ, still stress is increasing because the force is increasing. But what happens to strain is now not directly proportional to stress. ಏನಾಗ್ತೈತ್ರಿ ನಾವು ಫೋರ್ಸ್ ಹೆಚ್ಚು ಮಾಡ್ದಂಗ ಸ್ಟ್ರೆಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ಲಾಗತೈತಿ ಆದ್ರೆ ಸ್ಟ್ರೇನ್ suddenly increase ಆಗೋದು taking a time, right? It is now not directly proportional to each other. ಹೌದಾ strain increase ಆಗ್ತೈತಿ, strain is increasing. See in this B A to B strain is increasing, right? Strain is moving from A to B, but it is not directly proportional to ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಹಿಂಗೆ ಹೋಗ್ತಿತ್ತು, right? Now as the force increase behind A ಅಂದ್ರೆ A ಗಿಂತ ಹೆಚ್ಚು ನಾವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದಪ್ಪ ಅಂದ್ರೆ stress increases but strain is not directly proportional to stress between A and B. ಏನು ಮಾಡಿದ್ರಿ ಇಲ್ಲಿ A ಅಂತ ಹಾಕೋದು. Further force increased, stress increases because the curve is like this. Stress increases, but strain and stress are not directly proportional to each other. Strain and stress is not directly proportional to each other, and within this curve the maximum stress is obtained up to B. So this B point is called as yield strength, or I can say yield point. Yield strength ಅಂತಾರೆ, yield point ಅಂತಾರೆ. Still ಇಲ್ಲಿ ಮಟ್ಟ ಬಂದ್ರಿ B ತಿಳ್ಕೊರೆ ಈ ಪಾಯಿಂಟ್ ಇಲ್ಲಿ ಮಟ್ಟ ಬಂದದ ನಾ ಎಷ್ಟು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ FB ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ ಇದು FB ಅಂತ ತಿಳ್ಕೊಂಡು ಹೌದಾ FB ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ FB ನಾ ಫೋರ್ಸ್ ತಗೊಂಡೆಪ್ಪ ಅಂತಂದ್ರೆ if the deformation force is removed, still body regains its original shape and size, right? Once this force is removed, still body regains its original shape and size without any deformation, right? Without any further deformation, I can say that without any internal deformation, it is regaining its original shape and size after removal of force FB, right? I am telling this but we are not removing the force, but we are still increasing the force. What will happen further if I increase the force between between CD and BC? What will happen here is force is increasing. Force is increasing means I have applied 22, then certainly I will go to the 25 Newton. It is FC alpha. So as the force is increasing, now strain increases. Now the strain increases, but stress decreases. See the curve, like this curve going down. Going down means stress go on decreasing, but strain increasing. Right? So strain increasing. So it reaches point C. At this point C, I have applied 25 Newton of force. If I remove this 25 Newton of force, if the body is initially this much size, and by applying the force 25 Newton, it becomes like this. ಇಲ್ಲಿ ಮಟ್ಟ ಬಂದದ್ದು ಮೊದಲು ಬಾಡಿ ಸೈಜ್ ಎಷ್ಟಿತ್ತು ಇಲ್ಲಿ ಮಟ್ಟ ಐತಿ ಹೌದಾ ನಾ ಫೋರ್ಸ್ ಎಫ್ ಸಿ ಅಪ್ಲೈ ಮಾಡಿದ್ದಕ್ಕೆ ಈಗ ಇಲ್ಲಿ ಮಟ್ಟ ಬಂದಿರ್ಬೇಕು ನಮ್ಗೆ ನಾ ಎಫ್ ಸಿ ತೆಗೆದಪ್ಪ ಅಂದ್ರೆ ಅದು ಆ್ಯಕ್ಚುಲಿ ಇಲ್ಲಿ ಬರಬೇಕು ಬಟ್ ಬಿಡ್ಬೇಕು ಇಲ್ಲಿ ಬಿಕಾಸ್ ಪರ್ಮನೆಂಟ್ ಡಿಫಾರ್ಮೇಷನ್ ಆಗಿರ್ತೈತಿ ಸ್ವಲ್ಪ when this FC force is applied on the body, when FC force is removed, body does not gain its original shape and size. Of course, it is coming back. It is what under the elastic limit. Elasticity aiti, but it is not gaining its actual size. How the initial length istitapa atandra tilkori. Initial length istitapa atandra. How the new force apply madiri. ಇಲ್ಲಿ ಮಟ್ಟ ಬಂದದ್ದು ಯಾವ ಫೋರ್ಸ್ ಗೆ ಅದು FC force apply ಮಾಡಿ ಇಲ್ಲಿ ಮಟ್ಟ ಬಂತು. If I remove this FC force now, actually ಇಲ್ಲಿ ಮಟ್ಟ ಬರಬೇಕು ಬಟ್ ಇಲ್ಲಿ ಮಟ್ಟ ಬರೋದು ಇಲ್ಲಿ ಮಟ್ಟ ಬರಲ್ಲ. So this thing whatever here I am getting here, this is called the permanent set. This permanent set obtained as a force FC. ಅದೇ ಇಲ್ಲಿ ಈ ಫೋರ್ಸ್ ಬರುತ್ತೆ. So this is called permanent force, permanent set force. Called permanent set force FC. So when this permanent set force FC is applied, body does not regain its original size, but some permanent set will be taken place. That permanent set is less than 1% of its original length. Just kadime irutappa permanent set andre bhal kadime irutati 1% of the length ಗೆ kadime irutati. Suppose its length is 100 millimeter. Its length is 100 millimeter, right? Due to the permanent set, yes, length increase agutappa andre 1 millimeter ಅಷ್ಟೇ increase ಆಗಿದೆ. Very small, 1 millimeter ಅಷ್ಟೇ increase ಆಗಿದೆ. ಅದಕ್ಕಿಂತ ಕಡಿಮೆ increase ಆಗಿದೆ, but increase ಆಗಿದೆ, right? Now furthermore, from this point C, as the load is increasing, ಮತ್ತೆ ನಾವು force ಅನ್ನು increase ಮಾಡ್ಕೊತ ಹೋಗ್ತೀವಿ. As the force is go on increasing, say in the same manner strain go on increasing, ಹಂಗೆ strain increase ಆಗ್ತಾ ಹೋಗ್ತೈತೆ ಹೌದಾ ಬಟ್ ಸ್ಟ್ರೆಸ್ increase ಆಗ್ತೈತೆ ನೋಡಿ ಸ್ಟ್ರೆಸ್ increase ಆಗಲ್ಲ because it is going up from C to D, it is upward curve. Stress go on increasing ಆಗ್ತೈತೆ. So silly point, as the deformation force increases, furthermore stress increases and strain also increases, but now stress and strain are not proportional to each other. Stress ಮತ್ತು strain ಯಾವುದಕ್ಕೂ ಪ್ರಪೋರ್ಷನಲ್ ಇಲ್ಲ ಹೌದಾ ಇದು ಸಡನ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಆದರೆ ಇದು ಸಡನ್ಲಿ ಒಂದು ಸ್ವಲ್ಪ ಇನ್ಕ್ರೀಸ್ ಆಗಿರ್ತೈತಿ ಸ್ಟ್ರೆಸ್ ಬಹಳಷ್ಟು ಇನ್ಕ್ರೀಸ್ ಆದರೆ ಸ್ಟ್ರೈನ್ ಒಂದು ಸ್ವಲ್ಪ ಇನ್ಕ್ರೀಸ್ ಆಗಿರ್ತೈತಿ ಹಿಂಗಾಗಿ ಇಟ್ಸ್ ನಾಟ್ ಪ್ರಪೋರ್ಷನಲ್ ನೌ ಸೊ ಇಟ್ ರೀಚಸ್ ಪಾಯಿಂಟ್ ಡಿ ಸೊ ಪಾಯಿಂಟ್ ಡಿ ಇಸ್ ಕಾಲ್ಡ್ ಅಪ್ಪರ್ ಈಲ್ಡ್ ಲಿಮಿಟ್ ಇದಕ್ಕೆ ಏನಂತೀವಿ ಅಪ್ಪರ್ ಈಲ್ಡ್ ಪಾಯಿಂಟ್ ಅಂತೀವಿ ರೈಟ್ ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಅಪ್ಪರ್ ಈಲ್ಡ್ ಪಾಯಿಂಟ್ ಸೊ ಅಪ್ ಟು ದಿಸ್ we can say that as the stress increasing, strain is also increasing illi mata, but it is not directly proportional, right? Hang agtitri ee point ge ಅಂತಂದ್ರೆ ನಾವು ಹಿಂಗ್ ಬಾಡಿ ತಗೊಂಡ್ವಿ, we have taken a body like this, ಹಿಂಗ್ ತಗೊಂಡ್ವಿ, ಈ ಫೋರ್ಸ್ ಗೆ ಬಂದ ಕೂಡಲೇ ಬಾಡಿ ಹ್ಯಾಂಗ್ ಆಗ್ತಿತ್ತು ಅಂದ್ರೆ ಎಲ್ಲಿ ವೀಕ್ ಸೆಕ್ಷನ್ ಇರುತ್ತಲ್ಲ ಅಲ್ಲಿ ನೆಕ್ ಫಾರ್ಮ್ ಆಗ್ತದೆ. ನೆಕ್ ಫಾರ್ಮ್ ಅಂದ್ರೆ ಏರಿಯಾ ಕಡಿಮೆ ಆಗಲ್ಲ ಶುರು ಮಾಡ್ತೀವಿ ಒಂದು ಕಡೆ ಎಲ್ಲರೆ ನೆಕ್ ಫಾರ್ಮ್ ಆಗ್ತದೆ ಅಥವಾ ಶೋಲ್ಡರ್ ಫಾರ್ಮ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಶೋಲ್ಡರ್ ಸರಿ ಫಾರ್ಮ್ ಅಂತೀವಿ ಅಥವಾ ನೆಕ್ ಫಾರ್ಮಿಂಗ್ ಅಂತೀವಿ. ಸೊ ನೆಕ್ ಇಸ್ ಫಾರ್ಮಿಂಗ್ at certain point neck is forming at what load? At the force FD, or you can say upper yield point. When the force applied is upper yield point, neck formation takes place. ಇನ್ನು ಮುಂದೆ ಏನಾಗ್ತೈತ್ರಿ, ಇನ್ನು ಮುಂದೆ ನೀವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡೋದೇ ಬೇಡ, ಸುಮ್ಮನೆ ನೀವು ಫೋರ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಟರು, ಸಪೋಸ್ ಐ ಹ್ಯಾವ್ ಅಪ್ಲೈಡ್ ಎಫ್ ಡಿ 50 ನ್ಯೂಟನ್, ನಾ ಫೋರ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡೋದಿಲ್ಲ, ಕಾನ್ಸ್ಟೆಂಟ್ ಇಡ್ತೀನಿ ರೀ ಬರೇ, ಬಟ್ ಏನಾಗ್ತೈತಿ, ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಟರು ಸ್ಟ್ರೆಸ್ ಗೋ ಆನ್ ಡಿಕ್ರೀಸಿಂಗ್, ಸಿ ಸ್ಟ್ರೆಸ್ ಇಸ್ ಕಮಿಂಗ್ ಡೌನ್, ಸ್ಟ್ರೆಸ್ ಗೋ ಆನ್ ಡಿಕ್ರೀಸಿಂಗ್ ಬಟ್ ಸ್ಟ್ರೈನ್ ಗೋ ಆನ್ ಇನ್ಕ್ರೀಸಿಂಗ್, ಸ್ಟ್ರೈನ್ ಹಂಗೆ ಹೆಚ್ಚಾಕೋತ ಹೋಗ್ತೈತಿ, ಲೆಂತ್ ಹಂಗೆ ಹೆಚ್ಚಾಕೋತ ಹೋಗ್ತೈತಿ, ಆದ್ರೆ ಸ್ಟ್ರೆಸ್ ಕಡಿಮೆ ಆಗೋದು ಹೋಗ್ತೈತಿ, ರೈಟ್. ಸೊ at particular point, at particular length, the body get failed, ಮುರಿದು ಬರ್ತೈತಿ, ಎಲ್ಲಿ ಈ ಪಾಯಿಂಟಿಗೆ ಮುರಿಯುತ್ತೆ, that point is called as fracture point. So this is what happening when you apply load on the body. So I'll explain it once again, ಮತ್ತೊಮ್ಮೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ಕೇಳಿ. ಸೊ ಏನು ಮಾಡ್ತಾರಪ್ಪ ಅಂದ್ರೆ ಒಂದು ರಾಡ್, ವಿಲ್ ಟೇಕ್ ಒನ್ ರಾಡ್ and force is applied. See, as the force go on increasing, stress increases and also strain. This thing happen up to a particular limit. That limit is called as the proportionality limit. Up to the proportionality limit, it is happening. Even if I remove this force, even if I remove FA force, body will regain its original shape and size. Not at all the issue. It will regain, right? But we are not removing the force, but we are applying the force. Sudden FA ಆದ ನಂತರನು behind the FA and go on increasing the force means still stress and strain are increasing. Then stress reaches the maximum point. That is called as the yield point, lower yield point, or you can say yield point simply, or you can say elastic limit. So up to the elastic limit, stress and strain are directly proportional to each other. That is point B. Right. Furthermore, if I apply the force, deformation force, stress decreases, but strain increases. So at point C, you can say stress is decreased, but strain increased, right? And at point C, if I remove this force, body regains its shape, but not the size. Size regain ಮಾಡೋದಿಲ್ಲ, ಸ್ವಲ್ಪ ಸೆಟ್ ಆಗಿರ್ತೈತಿ, ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಲೆಂತ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿರ್ತೈತಿ. That increase is called as a permanent set, and that force is called as permanent set force, right? So furthermore, behind this permanent set force go on increasing means within a short force, stress increase suddenly, stress ಬಹಳಷ್ಟು ಹೆಚ್ಚು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತೈತಿ, so as strain ಬಹಳಷ್ಟು ಹೆಚ್ಚು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತೈತಿ. ನೋಡ್ರಿ, stress ಕಡಿಮೆ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ, strain ಬಹಳ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. If I apply the load further, suddenly stress increased bit lesser, but strain increased more, right? So this point is called as the upper yield point. So furthermore, if I keep the load constant or deformation force constant, then stress remains go on decreasing, but strain go on increasing. Yes, strain fall ಆಗ್ತೈತಿ, strain ಹೆಚ್ಚಾಗುತ್ತೆ, ಯಾಕೆ ಹೆಚ್ಚಾಗುತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ neck formation ಆಗಿರುತ್ತೆ, right? Neck formation ಆಗಿರುತ್ತೆ. Up to certain strain, body withstand, then furthermore body breaks. So that is point is E is called the fracture. So this is regarding the curve. So I'll write some points here. Just take a screenshot of this. I'll run this just to understand the points. I have made this. This is a screenshot of the. You have to draw this figure very neatly. Neat figure try ಮಾಡಿ ಬರಬೇಕು ಡಯಾಗ್ರಾಮ್. ಹೆಂಗ್ರಿ ಆನೆ ತೆಗಿತಿರ್ತಾರಲ್ಲ, ಸಣ್ಣ ಹುಡುಗರದಾಗ ಆನೆ ತೆಗಿತಾರೆ, ನೀವು ಸೊಂಡಿ ತೊಗೊಂಡು ಹಿಂಗೆ ಮಾಡಿ ಮಾಡ್ತೀವಿ, ಹಂಗೆ ಅದು ನೋಡಿ, ಇದು ಸೊಂಡಿ, ಇದು ಡೂಬ, ಇದು ಅದನ್ನು ಡೂಬ, ಹೌದಾ? ಅರ್ಧ ಆನೆ ಮಾಡಿ ಪೂರ್ತಿ ಕಾಲಿಗೆ ತೆಗಿಲಕ್ಕೆ ಹೋಗ್ತಾರೆ, ರೈಟ್? ಸೊ ಜಸ್ಟ್ ಲೈಕ್ ದಿಸ್, ಲೈಕ್ ಎಲಿಫೆಂಟ್ ಯು ಆರ್ ಡ್ರಾಯಿಂಗ್. ಸೊ ಇಟ್ ಇಸ್ ಸಿಂಪಲ್, ರೈಟ್? ಸೊ ಟೇಕ್ ಅ ಸ್ಕ್ರೀನ್ಶಾಟ್. ಐ ವಿಲ್ ಗಿವ್ ಅ ನೋಟ್ಸ್ ರಿಗಾರ್ಡಿಂಗ್ ದಿಸ್. So let us write the notes regarding this. So point AB, I go on writing. You also do the same between A and B. As the force increases, both stress and strain increases. It is not O, it is OA. And point A is called is called proportionality limit. Proportional limit, proportional limit. Right? So within this up to A, I can say that stress and strain are directly proportional to each other. Then further point AB, as the deformation force increases, increases, stress and strain increases, but not linearly, right? These are not linear because you can say here a small curve is there, up to 8, a small curve is there. For that reason it is not linear. I can say that it is not linear. And point B is called the elastic limit or yield point. Or I can say elastic limit. So next it is B to C. So B to C, what will happen as the deformation force increases, as the deformation force increases, strain increases rapidly. So strain increases rapidly means strain is increasing, but stress is not increasing. So, but not more than that, right? More than stress, right? And to this force, to force FC, permanent deformation of body takes place, called permanent set, right? It is called as a permanent set. So this is what the permanent set. And I can say that this OC is under elastic region. Elastic region means what? Still, if I remove this force, FC force, body regains. It's not original shape, but it is regains shape and size, but not origin. Once the load crossing this C, body becomes plastic. After this load, body does not regain any original shape and size. It becomes plastic body. So between CD, as the further force increases, strain increases more rapidly than stress and reaches ultimate stress. So what is ultimate stress? Ultimate stress is the stress obtained when maximum force is applied. I can say that when the body starts breaking, the force and the body starts breaking is called ultimate strength, or I can say ultimate stress. So ultimate stress. So furthermore, between DE, as the force increases, as the force remains constant, body, or you can say strain, go on increasing. Strain increases, but stress decreases. Stress decreases. This is because neck formation takes place. Neck formation takes place, and at point E, body fracture, body get failed. Failed means what? It break. Body break. Right? So this is regarding the stress strain diagram. And briefly I have written certain points. Some points verbally. You can go through the notes and make perfect points. I'm going to go through the notes. Everything is there in the notes. Just read it and make your own notes in the notebook, as I used to tell you that. Read the notes, watch the video and make your own note. Hope you are making or hope you are writing the notes. So I'll stop here today's concept, and this concept is also very important. It may appear like 3 marks to the 5 marks for your examination. So very important. Sometimes it may ask like only draw the figure, only draw the stress strain diagram for ductile material. This is ductile material. If I take a brittle material, it is totally different. If I take malleable material, totally different. I'll draw. Next coming class, forthcoming classes, I'll draw the separate graph for ductile material and brittle material and everything I'll give. Right? Up to that, you remember this curve is for the ductile material. And so many times in the examination, ductile material is only asked. You have to draw the figure like Ani, as I told, it is an elephant, and you have to mark each and every point, and you have to write each and every point where is what, and don't forget to write OC. Up to OC it is elastic region, and behind C it is the plastic region, right? So take a screenshot and make your own notes. So this is all the today's class. I'll stop here. I will continue in the next class, and in the next class we will see what are the kinds of the elastic limit, right? So I'll stop here. I'll continue in the next class. Thank you.